Good morning, students. In previous classes, we learned this topic called change of states of matter. How the physical state of matter can be changed. We have three different physical states: solid, liquid, and gas. We discussed under two headings how we can change means by changing temperature, we can change the physical state by changing pressure. So in previous classes, we learned that by changing temperature, we can change from solid to liquid and liquid to gas. In today's class, we are going to learn, this is today's class. In this case, we are going to learn solid to gases. Generally, solid to liquid, liquid to gas. And we can change from solid to gas directly also. It is like this. Take for example, ammonium chloride. Leave about this chemical. Let us check naphthalene ball. It is a solid. Once it is kept under, once it is exposed to air, or these are generally kept inside the clothes. After 3 or 4 days, you can see the decrease in size of the naphthalene balls. This clearly indicates that, and you can get the aroma from the naphthalene balls. The solid naphthalene ball is converted to gases there. That is one. That is one application we can see in daily life. Chemically, if we check, take ammonium chloride, which is white in color, take in a small glass, watch a glass and heat it. You can see the arrangement of this experiment. A burner with a stand on this a water glass, inside ammonium chloride. A funnel is kept and a cotton plug is kept at the outlet of this funnel. If we are heating this, ammonium chloride, which is a solid, converts to gas. This gas is gaseous. As there is no outlet for this, it sticks to that walls of that funnel. So here solid converts to gas, and gas again converts to solid here. So when ammonium chloride is heated in a beaker, it is converted to gas state directly. This process of converting the solid substance to gas is said to be sublimation. Sublimation means the process of converting solid state to gaseous state is said to be sublimation, which we can see in case of camphor also. Camphor, when you burn it, it converts from solid to gas. So this is the different examples. So changing of solid state to gas state without changing into liquid state, it is called sublimation. Similarly, we can change the state from gas to solid also. So if the state of the matter changes from gas to solid without coming to liquid, it is called deposition. You can see in this experiment very clearly, ammonium chloride is a solid. It is converted to gas. As there is no outlet, again this gas, it is solidified and attaches to the walls of the funnel. You can see this ammonium chloride is solidified, you can see here. So this gas is converted to solid here. It is deposited. It is called deposition. Solid to gas is said to be sublimation. Gas to solid is said to be deposition. These differences you have to know. So, basing on the physical states, you have the chart like this. If a system is changing from solid to liquid, it is called melting or fusion. If a system is changing from liquid to solid, it is called solidification. If a system is changing from liquid to gas, it is called vaporization. If a system is changing from gas to liquid, it is called condensation. If a system changing from solid to gas, it is sublimation. If a system changing from gas to solid, it is called deposition. We can see very clearly about the three different states and their interconversion from one state to other state. Now we are going to discuss about second point. Previous we discussed about by changing the temperature we can change the state of system. Now second one is by changing pressure also we can change the state of system. This easily we can understand. You heard about dry ice, I think so. This dry ice, we use it in our science lab also for science week. This dry ice actually it is CO2 gas which is in solid state. This dry ice means solid CO2, solid carbon dioxide, which is at high pressure. First they will take a gaseous carbon dioxide CO2 and they will apply more pressure. Under high pressure this gaseous CO2 convert to solid. This solid CO2 seems to be like ice, so it is called dry ice, where there is no water but still it is like ice, seems to be ice. Now question comes, how this gas is converted to solid? Just by applying pressure. How it happened? Let's see. Generally in solids we have this image very clearly here. In solids particles are very close to each other. In liquids they are little bit far from each other. In gases the particles are very far from each other. Basing on the distance we can tell which is solid, which is liquid, which is gas. Very far away from each other in gaseous state. Very close in case of the solids. In their medium distance it is a liquid. So very clearly we can see distance between particles in solid is very less. In solid is very less. Distance between particles is very high in gases. Distance between particles is medium in liquid state. So just imagine we taken a gases CO2 in which particles are very far away from each other like this. We taken this gas in a cylinder and we applied high pressure. When apply more high pressure, these gaseous particles comes close to each other. They comes close to each other and they convert to solid. Means they are very close to each other. Attraction increases between particles and it is converted to solid. This is how a gas converts to solid. Just by applying pressure it can be converted. Not only here, you can see other example like your gaseous CO2. In cool drinks you can see this. In cool drinks you can see they'll pump the gaseous CO2 into that cool drinks at high pressure. It is converted to liquid inside. Because of high pressure it is converted to liquid. So we can tell the gaseous substance can be converted to liquid. It is called liquefying of gases. You can see this. Converting of gases to liquid is said to be liquefying of gases. So by applying pressure and reducing temperature, a gas can be liquefied. A gas can be converted to liquid very easily. Remember this main point. A gas can be converted to liquid easily by applying more pressure and less temperature. So from this we can conclude that pressure and temperature determines the state of substance, whether it is solid, liquid or gas. Next we must learn about temperature and the unit of temperature. Previously I already said that temperature is a quantity that determines that or measurement of heat it is. Temperature in Celsius it is Celsius, in SI it is called Kelvin. Generally we use Celsius in daily life. Celsius scale is a measurement of temperature which we use in our daily life. The common unit for measuring temperature like your boiling point, melting point, all these are done under degrees Celsius. Boiling point of water 100 degrees Celsius. Freezing point of ice 0 degrees. Melting point of ice 0 degrees Celsius. So degrees Celsius we use the word degrees Celsius. which is written as degrees Celsius. In if you see the thermometer also, in thermometer also we can say degrees Celsius on thermometers. So we use even thermometers. In thermometers also we use degrees Celsius for measuring temperature of a particular substance. See, the melting point of ice on degrees Celsius is 0 degrees Celsius. Boiling point of water is 100 degrees Celsius. So generally in daily life we use the degree Celsius, which is CGS unit. We have SI unit of temperature, that is Kelvin scale of temperature. Kelvin is a scientist name. Generally this Kelvin scale used in science labs, which is represented by capital K. When you're writing this capital K, you won't use a degree. Remember, you won't use the sign degree. So this Kelvin scale temperature has always positive values. That is one major difference between Kelvin scale and degree Celsius. In degree Celsius we have negative temperature, but in Kelvin scale we don't have negative temperature, only positive. So we have to learn the main point, that is how to convert degree Celsius to Kelvin. It is like this. 0 degrees Celsius means 273 Kelvin. You can convert this like this. Kelvin scale is equals to temperature of a Celsius scale plus 273. So remember this main formula, that is temperature on Kelvin scale is equals to temperature on Celsius scale plus 273. So with the help of this we can convert Kelvin scale to degrees Celsius scale, and we can convert degrees Celsius to Kelvin scale. Let us solve some problems. Convert the temperature of 25 degrees Celsius to Kelvin. I given 25 degrees Celsius. I am asking you to convert it into Kelvin scale. We know the formula. Kelvin scale is equals to Celsius scale plus 273. Given Celsius scale, so Celsius scale is 25 plus 273, which is 298 Kelvin. It's very simple. So for 25 degrees Celsius means Kelvin is 298 Kelvin. Similarly, now I'm giving 300 Kelvin. I'm asking you to convert into Celsius scale. Kelvin scale is equals to degrees Celsius scale plus 273. In the question, 300 Kelvin is given, which is equals to degrees Celsius plus 273. But I want degrees Celsius now. Keep right side 273 towards left side, minus 273. You will get 27 degrees Celsius. Means 300 Kelvin means 27 degrees Celsius. So we can tell very clearly that from above discussion that to convert temperature from degrees Celsius to Kelvin, we have to add 273. I am repeating, to convert temperature scale from degrees Celsius to Kelvin, we have to add 273. To convert Kelvin to degrees Celsius, you have to subtract 273. To convert Kelvin to Celsius, we have to subtract 273 from Kelvin temperature. We can see based on these two examples. To convert to degrees Celsius, in sample problem 1, to convert degrees Celsius to Kelvin, we added 273. In sample problem 2, we have seen very clearly, to convert from Kelvin to degrees Celsius, we subtracted 273. So this is story of temperature scale. So in this class we learned about temperature scale, as well as by applying a pressure how we can convert the state of a system. And these are 3 different states of a system, and these are different definitions. Completely learn this different states of and their definitions. And this is a worksheet for you. Solve this worksheet. I think it is very clear to you. First one is converting temperature scales. Kelvin is given, convert as degrees Celsius. So next second question is about physical state of water at 250 degrees and 100 degrees. Third question is for any substance, why does the temperature remains constant during change of state? Observe this question clearly and note down the answer. Suggest a method to liquefy atmospheric gases. How to convert gases to liquid? That is what you have to see in this question. How to convert? So from previous topics, we can get all these answers. Write on running notes, in the running notes, all these questions. Thank you, friends.